All right. Class. Oh, come on. Let's try this again. Class.
Yes.
All right. So this is my 5th hour class today, deciding to get World Star famous as we go through the notes on this. So we're working on page 8 and 9 today. So let's take a look. So in my notebook, 7, 8, 9. So we already did the practice from this first problem. We already did this one right here. This was our warm-up. So now what did we say for this first part?
N plus 2.
So this one was n plus 2. And what was the other one?
Plus 3.
N plus 3. Then it was
Plus 4.
n plus 4. Very good. And so if I were to keep going, it would be n plus 5, n plus 6, right? Okay, good. Now, this next one says, here's visual pattern of dots. The number of dots, d of n, is a function of the step number n. The step number n, that means the term number. That means what is it in the sequence? Is it the first term? Is it the third term? Remember we had this question yesterday on our thing. We were referring to a certain term number. We skipped over the third term and fourth term. You guys remember that problem? Yeah, and it was like fifth term? Okay, good. That's what we're going for. All right, so let's go ahead and take a look. What values make sense for n in the situation? What values of n? So what numbers am I going to plug in there?
3.
A 3?
A 1, a 3.
A 1, a 3? Okay, here is, okay, this means the exact same thing, but I tell it as a joke instead. Okay, I tell it as a joke instead. How many people can you put on an airplane?
Okay.
The number of seats.
Okay. How many can you put on there?
About 150.
Okay. All right. Can you put negative people on there? No. No. The TSA says no. They'll get thrown off the plane, right? Okay, so no negatives. Yes? Okay, what about my homie that lost his arm in Iraq? Okay. Does he count? Is he a whole person?
Yes.
Don't Bro, you're going to kind of, yeah. Okay, so what types of numbers am I going to input for n? Whole numbers, right? Whole numbers. Whole numbers. That's what I'm going with this. So it's going to be whole numbers. Okay, so now if I'm doing this in steps, are we going to take a half step? No. You're not going to do this as a half step, and you're not going to do it as negatives. So what is the number set that I would say this would be? So think about it in mathematical terms. What types of numbers? Whole numbers, right? Okay. There's another term I could use. So whole number starts at 0, right? And then it's your natural. Okay, that's what I'm looking for, right? 0, and then it's your 1, 2, 3, right? And so on. That's what I was looking for. Now, it also could be referred to as positive integers, right? So it's numbers that I'm going to be plugging into here that is going to be only positive and only integers. So I can't have fractions, can't have decimals. So it'd say whole numbers. Or positive integers. There we go. Positive integers. Now, this next part, me and my previous algebra class, we almost got a fight over this one. Okay? Someone got salty because I called on them. Okay? So, we're not going to be like that. I'm telling you, I cannot be World Star famous this year. All right, so number 2, it says complete the table for steps 1 to 5. Okay, let's see what we have here. So what this means is I'm taking my previous, so D of 1 is 1. That was my first dot. The next one is I took my answer from 1 and then added 2. So I get a grand total of. So if I'm looking at my dots right here, I got 3 dots, right? Okay, good. I got 3 dots. So if I'm looking, I got 1 dot, I got 3 dots. How many dots do I have here? Okay, 6 dots. How many dots do I have here? 10 dots. Very good. All right, let's see if we can figure out the pattern for this. So the pattern's super important. Math is patterns. Okay, life is patterns. If you can figure it out, then you're a winner at life. So this is the answer from the previous one plus 2. This is the answer of the previous one plus 3, right? Okay, so what am I going to write for this next one? D of 3, which is my answer from my third one, plus 4, which gives me 10. Okay, because the answer is 6, right? So it's going to be 6 plus 4 is 10, right? Okay, so now let's do it again. So what am I writing for 5? D of 4 plus 5, right? Which gives me 15. All right, so now hopefully, I'm telling you, it was like quiet. So it was bad. I found out I have like 3 crickets in this classroom. That's how quiet it was. Okay, yeah. So crickets and everything. It was super awkward. All right. Anyway, so the patterns. Okay, y'all got the answer to the previous ones. Now let's see. Now I'm gonna throw out one for you, and then you're gonna tell me what it's gonna be. So if you look at this, this is what I'm going for, okay? Though it's the n, that's the term, right? So I want to know what would it be for the 20th? Think about it. Think about it. Think about it. I want everyone pondering something right now. All right, so I know you guys got this. I know you do. So we're pondering this right now. So anyone have an answer? Because I have a prize sticker for this one. Yes. 58. Write it out though. Can you write it out? That's what I want. Write it out. So it would be D of 19 plus 20, and you came up with 58? Okay, pretty good. Good job. That is exactly it for your water bottle when you get it. Okay? All right. So it's going to be, do you guys see the pattern on this now? So the term, it's the same as what I'm adding, isn't it? It's the same as what I'm adding. But then for this one right here, I have to add it from the previous one, right? So the answer from the previous one, which is my D of 1, right? Yes? Okay, so there's my previous one. Now, let's take a look at 3 to see if this works out. So on 3, it says, following the pattern in the table, write an equation for D of n in terms of the previous step. So I want to know what the nth term is. Same patterns as what we were doing. Same patterns. So the nth term. All right, let's see. Anyone else? What you got? Go ahead. Try it. Listen, don't be afraid to get it wrong. Don't ever be afraid to get it wrong. If you never try, you get it wrong all the time.
D of n minus 1 plus n.
Excellent. That is perfect. D of n minus 1 plus n. Perfect. Exactly right. Because if you notice, whatever term it was, right? That's how much we were adding, right? But didn't we add the d of from the previous term, right? So this is
What is the D of? Is it like
d is it's the function of what we have from previously. So that's what it's referring to. It's referring to some function that I get. So some output of the previous function. So that whatever my answer was from d of 3. So d of 3, was what? So my function of 3 came out to be 6, right? So this was 6 plus 4, which gave me 10.
Oh, okay.
Does that make sense now?
Yeah. Now it does. At first it wasn't making any sense.
Okay, now it does?
Yeah.
Oh, good job, good job. Okay, so that is perfect, absolutely correct. Good job. Okay, I'm gonna throw a sticker at you here in a minute. You're gonna get Pickle Rick. Okay. Anyway, all right. So let's take a look at the back side here. Says consider the same triangular pattern. Is the sequence defined by the number of dots in each step arithmetic, geometric, or neither? First, you have to remember what each one is. Okay, let's try this. Class,
Yes.
what is arithmetic?
Adding or subtracting.
Adding, subtracting. So everyone should have been saying adding, subtracting. All right, let's try this again. Class,
Yes.
what was arithmetic?
Adding or subtracting.
Adding, subtracting, right? So, what is geometric?
Multiplication or division.
Yeah, multiplying or dividing, right? Multiplying or dividing. So that's a good way of thinking about it. So every single time it's got to be like that. So let's go through and figure out what is it supposed to be. So if I'm going back to this, look at my numbers. My numbers are going to be 1, 3, 6, 10, 15, and so on. So arithmetic would be adding the same value every time. Geometric would be multiplying the same value every time. Now, let's take a look. Going from here to here, what's the difference from there to there? 2. What's the difference from there to there? 3. The difference is?
4.
The difference is 5. So is this arithmetic?
No.
Is it geometric?
No.
So this is? Neither. Neither or neither. Depends where you come from.
Data or data.
So it is neither. Okay. Explain how I know. Okay. Arithmetic. Okay.
The jiggle, the change was real.
Okay. So arithmetic would has to go up by the same amount. I'm sorry, my penmanship is bad. Two, can you write an expression of the number of dots in step n without using the value of d from the previous step? All right, so now this is going to be a yes or no. So, who says yes? I got yeses, and who says no? Who didn't raise your hand at all? Go ahead, raise your hand now. Who has no clue? Raise your hand. Okay, all right, so for this one right here, if we're thinking about it, to be able to get this one, to get this one to get to the 10, I know I was adding 4, right? But I also have to have the number from before, don't I? So I had to have the number from before. So is it possible? Say no. No, it's not possible because I needed to actually figure that out. So I have to have the number before to get to the next one. So I can keep adding it. So this one's no. Okay? So, so it's just a no on that one. So we're going to use the first 5 terms in the sequence to see if it's arithmetic, geometric, or neither. Next, define the sequence recursively using the function notation. So now, this function notation is going to be new. Okay? It's similar to what we've done. But this is going to be the function notation for this. All right, so this one right here, we did this exact same one recently. Is this going to be arithmetic or geometric? Okay, it is going to be arithmetic. So there's arithmetic. Now, the function notation, which is super important. Okay, we did it on that previous one, right? We did it on the previous one. So now this would be an A of... We did it on the previous page.
A of
And...
n minus 10. I mean plus 10. Plus 10. Plus 10. Plus 10. What?
Yes, because I have to take the previous... answer. And then plus 10 to get the next one. Okay, so watch. My initial A of 1 is equal to 30. That is my initial number here. Okay, let's see if this works out now. Let's see if you guys could actually understand this. So now, if I wanted the second term, I'd put in a 2 here, right? So 2 minus 1 is 1. So what is A of 1? 30 plus 10 is? And that's the next term, isn't it? Does that make sense now? Okay, let's try it again. If I want the third term, okay, third term. So that means I'm going to plug in 3 here, right? So 3 minus 1 is? 2. So the second term here is 40. So the A of this one is 40 plus 10 is? So the third term is 50. Mind blown, right? Okay, let's try it. Let's do it some more, okay? So let's take a look at this next one now. So on 2, you say geometric. Why do you say geometric? Dividing by 2? Okay, that's good. All right, geometric. Geometric. So I'm going to write my function as b of n minus 1 because I'm taking the previous term, right? And then I would do what? Divide by 2 or multiply by 1/2. It means the same thing. And what is my initial? B of 1, the first term is 80. There we go. All right. So we're going to do this again. I'm going to show you mathematically how this is working out. So let's try and figure out the fourth term. So right here, let's see. If it was b of 4. So to figure out b of 4, okay, so I would plug in a 4 here, right? 4 minus 1 is 3. So that means b of 3. 1, 2, 3. That's b of 3, right? So now it's going to be 20 times a half. What is half of 20? So my next term has to be 10. A little bit more sense? Okay. All right, let's take a look at 3 then. Let's take a look at 3. So, what is that one going to be? Geometric? You say geometric. Anyone else agree geometric?
Yes.
I got one yes. Yes? Yes, whole bunch of yeses. Okay, so, geometric. So, geometric, I would write
C
of
n minus 1 times 2
times 2, and my initial
is C of 1 equals 1.
1. Yep, my initial is 1. Mm-hmm.
That's why I was stressing that show.
It's, yeah, I'm telling you, I don't like the way geometry is even, like they make us teach a certain way and certain things. It's not even like practical math anymore. So, yeah. So this is patterns. All right, so now let's take a look at 4. All right, so 4, what do we think 4 is? Geometric? Geometric? Okay.
2 times 1 half. Or is it minus 1 half?
Okay, so geometric. And so it's going to be d of
N minus 1
n minus 1,
times 1 half
1 half, and my d of 1
is D1
is 1, right?
1, yeah.
Very good. So I keep taking, so each one is times, right? Okay, half. What about E? Arithmetic. Okay, so arithmetic. So I'm going to say that's going to be E of n minus 1, right? Because it's going to take the previous answer. And now what do I do with it? Minus 7. Excellent. So E of
N minus 1
1 is 20. Remember our starting place. It's my initial. Where am I starting this pattern at? Yeah. So everything is dependent on my initial value right here. So I could figure out the pattern and the sequences of numbers if I knew where I start at. So it's kind of like giving you guys directions. I'm going to say, hey, you, Jake Wellen, I'm going to say, I want you to go down the hall, take 2 lefts and then a right. Okay? Okay, so now where are we starting at? Okay, in this case, we would be starting right here. Okay, but what if this was not where we were supposed to start at? What if we were starting in the 900 building and I gave you the directions for the 900 building? That would not be very good, right? Or be like, oh, hey, let's go to Lolo's. Okay, yeah, Lolo's is just like, you know, just down. So I'd say it's just around the corner. Just take a left over on, you know, Central. Okay, so, but the problem is, where are we starting at? Lolo's good. I'm telling you, the chicken and waffles. Oh, no. I'm telling you that butter that they got. Oh, don't you? Yeah, that whipped butter. Oh man, I'm telling you, you get it like you get the chicken, you get the waffle, and then you put the syrup on that warm syrup. Ooh, ooh. I don't drink Kool-Aid because it's like diabetes in a bottle. Okay, it's that much sugar. All right. So let's take a look at this last one right here. That one's confusion?
Yes.
Okay, so let's look to see how it's going up.
It's like, it's neither. It's neither.
It's neither?
It's going
Plus 2, plus 4.
No, it's times. It's times. Well, it's like multiplying what's going up next. So it's going like 2 and then plus 4 and then plus 6.
Can anyone give me an n values out of this? Say it. N plus 2 minus 1? Okay, so let's see. 2 times 1 is 2. Minus 1 is 1. That doesn't get me there, does it?
No.
Okay.
It's plus
But,
2.
huh?
It's plus 2.
It's plus 2?
And then the next one's plus 4.
I know, but I want to have a full n term. Go ahead. 2n plus 1. Very good. So this is going to be, look, 2 times 1 is 2, plus 1 is 3. 2 times 3 is 2 times 3 is 6, plus 1 is 7. 2 times 7 is 14, plus 1 is 15. There we go. So this one is neither. So I would say f of n minus 1. What am I going to put? Times 2 plus 1. Yeah, it's plus 1. And then I have my initial, which is f of is equal to. There we go. Super easy, right? All right. Okay, so now the bottom of the page is the lesson summary. Okay, so don't forget, like, share, and subscribe. Hit that notification button.